Okay. So the video, just going over what is a function, existing functions, create our own functions, and then testing. So what is a function? In math, we saw y equals f of x. Did they teach you about like dependent variables and independent variables in a prior math class? Okay. What would the independent variable be in this case? Okay. X. So it's kind of the value that we assign, like that we can put in as input. And then what's the dependent variable? Y. Yeah. And why do we call y the dependent variable?
It depends on the value of x.
Exactly. Like, so pretty much you enter a value x and then get a new value y. So this value y depends on the value that we put in for x. If we were to look at this in terms of a diagram, you essentially put in like an input x, the function will do something to that value, and then output a different value that depends on x. So if our function was something like x squared, we could input the value x equals 3, and then our output would be 3 times 3, which is 9. Everyone with me so far? Okay. If we wanted to look at a real world analogy, let's say we had a vending machine. And again, if we were to try to put this in terms of y equals f of x, what might our x or our input be in this case? Yeah, we have like this selection pad here where we can put in different numbers. And what is our output based on this number that we put in?
Whatever the snack is.
Yeah, exactly. So y, or our output, is the snack that comes out of the machine. We as users don't actually know how this machine works. Like, how is it that when we put in 53, this like spinning thing rotates and then a snack falls out and then we get it out? But we don't need to know how that works. We just have to know how to put in the input and what kind of input, and then we know that in return we'll get a snack or some output. And so when we talk about functions in computer science, it'll be similar to this, where we just have to know how to use the function, how to put information into it, so that we get some value out. Any questions here? Okay, so now putting it in terms of computer science terms, most of this code you should be familiar with. The only lines that are new will be lines 12 and 13, and then I guess also line 7, because we're using some special functions from the C math library. And so the function that we're using in this code is this sqrt. And so pretty much we do sqrt of 25, store that value in result 1, and we print it out to get result 1 is 5 and result 2 is 9. So can anyone guess what the sqrt function does? Yeah, Justin? Yeah, it does the square root. So the square root of 25 is 5, the square root of 81 is 9. Note that we don't know how this code actually works. What we do know is how to use it, that if we put in some numbers in the parentheses, we'll get the square root out in return. So x is the input that we're putting in the parentheses, and our output in this case is the square root result. Any questions here? People kind of see how the three analogies go together. Like functions in real life or in math or in computer science all work very similarly, where we feed in some input and then we get some other output. Okay, so in groups, I want you to try to define a function, kind of what are the components that go into a function, and then I want you to also try to guess why functions might be useful in computer science. So we'll have a pointer up here, and then Derek and Yeshua.
It can solve.
You gotta speak
I didn't say.
Oh.
Yeah, but I mean the only components you need in a function are the independent value and the dependent value. And it can be useful in CS functions.
I guess so CS is like big application.
Like I think the square root like helps you do like operations and stuff like that. So I'm assuming it's like functions allow the computer to do additional stuff or give you the ability to do more.
Okay, cool. We'll bring it back. So what would people say go into a function if we wanted to describe a function? Any ideas? Yes.
Dependent variable?
Yeah, so we'll be doing something with like inputs and outputs. So like we'll have like some independent variable that we use as input. We might have some independent output. Okay? So we'll say a function is like a block of code that can take an input. What can it do after it takes an input? Yep, so potentially create an output. And what happens in between those two steps?
Some operation.
Yeah, some sort of, like a function will do some specific task. And generally it will be a very well-defined task that it does. So something like sum together two numbers, take the square root, check if a letter is green, if we wanted to make a function for our Wordle project, like get color of letter, right? Some specific task, and then it can return an output. I will point out the can take input and can return an output, they're both optional. Not every function is going to take an input. In Friday's class, we were looking at an example to get a random number where we didn't actually put any input. We just called this function that gives us a random number, and we didn't put an input there, so the input is optional. And then likewise for the output, it's also optional, but most functions will generally have an input and output. Any questions here? Okay. And then you all discussed a little bit, why do we use functions? Do people have any ideas why functions might be useful? Yeah, Brian?
Let's say like function perform a certain task, and when needed, it will be called to perform that specific task at the moment.
Yeah. So one thing with that is like it can make the code clear. Like if we assign for a block of code, we create this function that says it does this, then it's very clear when someone sees our code, okay, this block of code does this specific thing. And if we can create these small little pieces, almost like Lego blocks, then we can put them together to build a large project that's clear to understand. All right, other ideas why functions might be useful?
Save time.
Save time? Why would it save time?
It do like harder mathematical problems.
Okay.
That will take you like multiple lines to do or something.
Yeah, so especially if we wanted to like call square root for a bunch of different numbers, if we didn't have a function, we might need to write that code a bunch of different times. But with functions, you can reuse code. So you have a block of code, you give it a name, and now anytime you want that block of code to run, you can just call the name, as opposed to calling all 10 lines over and over again. So reusing code is super critical. And can anyone think of any other reasons why functions might be useful? Okay. The last one I generally have is it's easier to test. So I know a lot of the code we've done so far have been less than 30 lines, so functions haven't been super necessary so far. But as we do bigger projects in this class, like when we do the whole blackjack simulator at the end of class, that might be closer to like 200 lines of code. And that's where it becomes really important that we have these smaller chunks that are maybe each like 15 lines. We just write like 15 lines of code, create it in its own function, test it to make sure it works before we use it in the bigger project. Okay. Any questions here? Cool. So we saw a diagram for the map usage of a function. For computer science, it's very similar. We just use different terminology. So instead of independent and dependent variable, we use for the input, we call it parameters. So values that we're passing into our functions, that we're going to use in our functions, we call those parameters. And then what we output is what we call the return value. And you can think of this as like the value that we are returning back to the user. So the user is going to run our function, and then we want to return them some value that they can use. Kind of like in the vending machine example, your parameter is the number that the user types in. The return value is the snack that you return back to the user. Make sense so far? Sure. Questions? Okay. So let's look at some existing functions that exist in C++. So absolute value, we include the C math header because this absolute value function is written in the C math file. And the way we would use it is, if we wanted to get the absolute value of negative 5.5, we would just call the name of the function. So in this case, it's called ABS. Then we put parentheses, and we pass in the value that we want to get. So what would the output of this code be? 5.5, because it will take the absolute value and return it. So what is the parameter in this case? Yeah, so it's the negative 5.5. This value that we pass to the function, that's our parameter. What's our return value in this problem? Yeah, so the function will do the calculations and will give us back 5.5, which we then print out. Make sense? Okay, let's see another example. So the pronounced strlen, it kind of stands for string length. This one is in the C string header file. You don't have to memorize where all these are. If I ever have you use an existing function, I'll let you know what file you have to include. And so this one will print out the length of a string. So notice right here, we're passing in this variable song. What is the value of song at this part in the code?
0. Wait, I'm sorry, 17.
So that's maybe the length, but what is the song variable? What value? Yeah, so song is defined up here. They use this char array. We could have done it with a string as well. And it's we will rock you. So the value that we're passing into this function is we will rock you. The function takes that whole phrase and then calculates how many letters are in the phrase, figures out there's 17, and then returns the value 17, which is what we print. Do people follow that? Okay. Yeah, question.
First, like since they did use char because they wanted the whole thing, they left it empty on purpose. After the song, like they left the like the index, like they left the 0.
This bracket. Okay. Don't worry too much about how they define this. This is like another way that you can essentially define a string.
Okay.
They try to do it with like a char array, and we'll learn about arrays later.
Okay,
Yeah.
and then return. So every time you do something like that, you gotta put return 0 as well.
The return 0 for the main function is optional. In our code, we haven't been doing return 0, and you don't need to do it. It's like an optional thing you can do in the main function. Yeah. So I probably could have just written this example better. I got a little bit lazy and just copied the screenshot. All right. The big thing I want to take away from here, though, is we need to specify what the data type is in the function. So in this example with absolute value, what is the data type that's accepted here as a parameter? A double. So what do you think would happen if we put a string? What if we did absolute value and in parentheses we put the word hello? You would get an error, right? So just like in the vending machine example, if you put a note card as input in the money slot, the vending machine would spit it out and say, we don't know what to do with this. Functions in computer science work very similarly. Later in class, we'll be creating our own functions, and we'll say exactly what data type we expect in the parameter. So in this problem, we expect a double, and then what is the return value? What is the data type for the return value? It's also a double, right? All right, in this example, we'll say the parameter is a string, so you have to pass in some sort of text. What is the return value type? An int, right? Because we're getting the length of the string. So, and the length of the string isn't going to be a decimal, so it's not going to be a double. We know it's always going to be a whole number, so the return type would be an int. One more example, we have this toLower function in the CC type file. This one takes, in this example, a capital A and outputs a lowercase a. So it takes any letter that the user puts in and converts it to lowercase. What is the expected data type for the parameter?
Char.
It's a char. So note that there's just single quotes around the A. So it takes a char. And what is the output? What is the return value data type? Yep. And what's the data type of that? A char. So note that once we get back lowercase a, we assign it to this value char ch. Yep. Question?
You don't memorize where it says CC type. You have to memorize all those.
No. So if I ever have you use an existing function, I'll let you know what you need to include. In this class, though, we'll mostly be creating our own functions. So, yeah. All right. Any other questions? Yeah.
I'm confused on the one before that we were not using,
Mhm.
the 17.
Yeah.
I get what it's doing, but that's not 17 characters, is it?
We can count. So 1, 2, space 3,
Oh, okay, the
4,
space.
5, 6,
Yeah,
7,
it is.
and then also the exclamation point. Yeah. All right. Any other questions? Okay. Cool. So notice in all of these cases, we were seeing how to call a function. Whenever we use this in the main function, this is what we call is calling a function, where it already exists and we just pass in a value to get the value back. For this next section, we're going to pivot to actually creating our own functions. And so when we create our own function, we have to put a little bit more information. So in this example, I've created a function that's called add. It asks the user for 2 numbers, adds them together, and then returns the sum back to the user. So let's take this piece by piece. Let's start with the parameters. So the parameters are our input. In this case, we want them to both be doubles because the user could put in something like 5.5 and 3.3. So we make the data type a double, and then we can choose whatever variable name we want here. So I called this double num1 and double num2, but we could have called this like double value1 and double value2. So we get to choose the named, but these would be our parameters. Any questions here on just the parameter part? Okay. The second part is the function name. So that goes right before the parentheses. And the function name is generally going to be a verb. When you name it, you get to create the name, but generally you should use a verb or an action because functions generally do something. So in this case, this function is going to be adding together 2 numbers, so we call it add. We could have called it add numbers. You have flexibility in naming it, but make sure you choose a descriptive name. And then the final part is the return type, the data type. So kind of how I've been asking you, like absolute value, what does that return? That returned a double. String length, what does that return? That returns an int. That's what you would put at the start of your function definition. Okay, a lot of information. Any questions so far? So note that the function is expected to return some sort of value of type double, and that's what we do with sum, because sum is a double, and so we return sum back to the user. When we do, in this line here, sum is equal to num1 plus num2, what are num1 and num2? Yeah, so they're the values that the user is going to put when they call our function. So if we were to switch to like this main function here, and we had that add function, we could have like double result, or we'll call it sum. And how can we use our function to get the sum of, let's say, like 5.2 and 3? So this is what it looked like. So how can we call our function? Yeah, so we just put in the name of our function, so it's add. So note that we don't have to put the return type when we're calling it. We have to put a lot more extra information when we create the function, but when you call the function, you just have to call it by its name, and that's it. So we have sum is equal to add, and the 2 values we want to do like the sum of 5.2 and 3. So what can we put in the parentheses? Yep, so like our first number, 5.2, and then the value 3. And we'll put a semicolon at the end. So note when we call the function, I didn't do like double 5.2, right? That was just when we create it so that the computer knows, okay, we're expecting a double. Good, the user has put in the double 5.2. Yeah.
When we create it, would it be in this as well? Like, where do we create?
Yeah, so for now we'll create our functions above the main function. So we would have something like double add, and then it's like double num1, double num2, and then and we return sum. So now, like at line 11, when the computer sees like this word add, it looks to see where it's seen it before. And it's like, oh, we had this code block up here. That's called add. So if we were to run this and we were to print out the sum, what would we expect the output to be? Yeah, so like sum those two together to get 8.2. Oh, Wi-Fi. Okay, well, we'll let it come back, but it would have printed out the sum is 8.2. We'll step through the code visualizer so that we can actually see how it works. I hope the Wi-Fi does come back though. All right. So let's say we wanted to create the function header for the absolute value problem. So the first thing we want to think about when we're creating the function is what is our return type. So what is the data type we want to return for absolute value? It's going to be a double. Then we have our function name. We can call this whatever we want. We'll just call it absolute ABS for short. And then the parameters. So this is the value that we're asking the user for. And what data type do we want as input? A double as well. So double, and then you can call it whatever you want. So I called it double num. You can call it what you want. And then at the end of our function, what is the keyword we can use to give a value back to the user?
Return.
Return. So let's say in this code, we calculated this variable absolute value, then we would return that back to the user. Any questions? Okay.
Did you do that on the adding one too? Like return.
Yep, so at the end of the adding one, we did return sum. Let's see if guessed is any better. Okay. Cool, so we're gonna go into the visualizer to do this absolute value problem, create our own absolute value function. So, can everyone see the screen? Okay, so up here, we'll create our absolute value function. So again, what's the return value going to be for absolute value? So we'll make it a double, just so that if the user puts in like 5.2 or negative 5.2, we can return back 5.2. Double, then we get to create the name. So I'll call it something like calculate absolute value. And then we put in here our input parameters. So what data type are we going to ask the user for? Double, and we can just call it num. Okay. So note that I like create the two curly braces and I hit enter a couple times. Make sure it's lined up with the first letter here before I actually go in and start coding. So in here, we want to ultimately calculate this absolute value variable. And how can we do it? What's like the first case we want to consider? Yeah, so we'll say if number is less than 0, then what is absolute value equal to? Yep. Okay. Else? So we know it's not negative. What do we want absolute value to be equal to? Yeah, num. You could also do num times 1. They're both the same thing. Cool. And then what do we do at the end of the function to give it back to the user?
Return.
Okay. And then we need to check. So what's the data type of absolute value? It's a double here, and that matches what we're expecting to give back to the user. So whatever you have in this last return statement, that data type should match what you have here. Yeah, question?
So it's another way of asking for the input.
Yeah, so the input is going to be this one here. So the user is going to give us some num. And then in the function, we use the num to figure out absolute value. And then that's what we give back to the user, the absolute value. Okay, so now if we want to actually use this code. So let's say we create a variable called result. How can we use the function that we created? Let's say we want to calculate the absolute value of negative 3.2. Yeah, so we want to use the name of the function that we created, and then we put the parentheses, and if we want to do negative 3.2, we can just put in that number exactly. And then we can see out the result. Okay, so let's step through this and see what happens. Okay, so note, even though we have all this code here, what line is the code actually going to start running at? Yeah, so no matter what you have here, the code always starts running at the main function. That's always the starting point for your code. So we start at line 14. We created this variable result, which is like referenced in this memory location here. And at line 16, we say result is equal to whatever calculate absolute value of negative 3.2 is. So what line do you think is going to run next?
4.
Yeah, so the code is going to see calculate absolute value and be like, where have I seen this before? So it's first going to think, is it a variable? And it's like, no, it's not a variable. Well, actually, okay, it's not going to think it's a variable because it has the parentheses. So it's really just going to see like, where's this function been created? And it will go up and see at line 4 is where we created it. So the next line that's going to run, this arrow jumps up to line 4. And notice, so let's just see that again. Initially, we just had one memory block for the main function. But notice once we create this new function and start running it, another memory block gets created. And they're two separate memory blocks. So the main function can't use any of these variables, and this function can't use this variable. That's why we have to pass values back and forth between them. So what is the value of num going to be? Yeah. Well, so right now we're just asking what num is, and that's just the input, and so it's going to be negative 3.2. I think this is one of the hardest concepts with functions. Do people understand why this num ended up being negative 3.2? All right, can someone explain to me why it's equal to negative 3.2? Josh?
Because it's inputted, so like when you put a calculate absolute value, the input is going to be negative 3.2, so that's going to be assigned to the variable double num.
Yeah, so when we call this function, it's getting mapped to here. So this input, negative 3.2, really corresponds to this like num. So num is being assigned the value negative 3.2. Does that make sense? Okay. So we check at line 6, is negative 3.2 less than 0, true or false? Oh yeah, question.
So you do in the int main
Mhm.
function first, and then you go and create the double calculate absolute value function.
Yep, like the main function ran first. So if we like started the code back at step 1, int main ran first. We see this line, calculate absolute value, and we're passing in negative 3.2. And so now the code jumps up to where calculate absolute value is. And it's saying, okay, what is the value that the user inputted? And we see they put in negative 3.2. So for the purpose of this function, num is going to be equal to negative 3.2. Okay, so negative 3.2 less than 0, true or false? True. So what line runs next? 7. What's going to be the value of absolute value? 3.2. And then what line is going to run next? So I heard some different ones. Pretty much we exit this if else statement, so the line 11 will go next. So absolute value, as you all said, becomes 3.2. And then we return the value in absolute value. What is the value stored in here? Yeah. 3.2 is stored here. So this function, once you have your return statement, the function ends. So we're going to step. We're going to hit the end of the function. And what line are we going to go back to? Yeah, 17. We haven't fully finished 16 yet. We were in the process of calculating absolute value. So what is this going to return?
Oh, 3.2.
3.2, and what are we going to do with the 3.2?
The science of result.
Yeah, right now result doesn't have a value yet. So we're going to put it here. Result is now equal to 3.2. And note that this memory block disappears because we're done with this function. So if we tried to call like this variable absolute value in the main function, the code would get confused. It's like, what are you talking about? Because in this main function block, the only variable we have is result. And so what are we going to print out here? What are we going to print out? Yeah, we'll print out 3.2. Okay.
Question.
Yes.
So you want to put the function below the main function? You don't need to put it on top?
Right now, we'll learn a different way on Friday where you can maybe create it later. But for now, we have to create it before. Because when this code runs and sees like calculate absolute value, it has to look earlier in the code to see where it was created. So yeah, right now when we create functions, we'll create it before the main function. Yeah. Good question. Any other questions? Okay. What happens if we modify this code and instead of calling this like double num as a parameter, what if we called this as value? What other changes? Oh yeah, what would happen right now?
Like you have to change the other things surrounding it.
Yeah, so the computer's gonna get confused like what num is in this case. So what can we do to fix it? Yeah, so we would just have to change each of these to value as well. But your code would work exactly the same. So I just use that as an example to show that you can name this parameter whatever you want. Just make sure that you use that same name inside of the function. Yep. Okay. So the cool thing with functions, we were talking about why functions might be useful. Let's say instead of storing it in the result, we just printed out the value directly. So we could do like cout, calculate absolute value. Now the cool thing is, let's say we wanted to calculate maybe like 5 different absolute values. Instead of copying and pasting this code, 5 times, we can now just call it by its name 5 times. So we could do something like that, and then we could put in different values. So like 0, 2.4, 5, -3, right? And this is one of the powerful parts of functions, is that we can now reuse this code a bunch of different times. We didn't have to, write this if statement 5 different times. Yep. People follow that? Okay. Cool. And if we were just to see what that would look like in the EdStem output, if we're to run that. Oh, I didn't put any endels. What was the question? What does it mean?
Yeah.
So the return, 0, 2.4. Cool, so that's our output. The return is saying, essentially at the end of the function, what value we want to give back to whoever called it. So in this case, we calculated the absolute value, but if we didn't give it back to the user, we wouldn't have that value in this main function. So it's just a way of specifying how to give something back to whoever called it. Any other questions? All right. Is it kind of making sense? With this, there's a lot of nuances, and really the best way to figure out those nuances is to do it in practice. So lab 7, starting on Wednesday, you'll have the chance to create your own functions, and that will hopefully help us see where we still have room to learn. Okay, let's just do one more example. So for the string length function, so in this case, we get a string from the user, we calculate the length, and then we want to return the length of the string. So what is the data type of the return value? Int. Cool. I'll let everyone think about this next one for a sec before I get the answer. What is the parameter data type that we want? Yeah, so in this case, we'll ask the user for a string, and you can name it whatever you want. I called it word. You could have called it something else. We calculate the length, and then what line goes at the end of the code. Return, and let's say we have a variable length. We would return the length. What data type would this length variable need to be? It would have to be an int, so that we return an int. One thing I'll show in the code we had here, let's say we did the calculate absolute value and we didn't pass in a double or a numeric value. Like let's say we passed in the word hello. Note what the error is. So the error is saying cannot convert this like char pointer, which is another way of creating a string. It's saying it can't convert that string to a double. Yeah.
You, I think you may have already answered this. So
Okay.
we can pick like any name for our function, but does it have to like correlate a little bit with something that we're talking about, or do we like put that in on top?
Yeah, so your function name should relate to what the function is doing.
And then, but that's the way that it'll know like to do the link and absolute value.
I mean, so the computer doesn't care what name you choose for the function, as long as you're consistent. Like when you call the function, you use the same name as how you created it. But the name should be descriptive so that we understand what it's doing.
So like, what about it?
Uh-huh.
Like, lets the computer know to get the absolute value.
Got it. Okay. So this, when the computer sees this word, calculate absolute value, it will look earlier in the code to see where that was created. And it will see here, we created this calculate absolute value function. So it just knows like this code is what needs to run.
Oh, okay.
Like it, when we looked at it in the visualizer here, if we were to visualize it one more time. So like line 16 is about to run. Calculate absolute value. So what line is going to run next?
4.
Yeah, so the computer is going to know to go back to line 4. And if you notice the red arrow, it jumps up to line 4 to run that. And then the way it was actually able to calculate absolute value, that was the if-else statement that we created.
That's what we'll do every single one.
You're saying like line 17, 18, 19? So it has to go in order. So first it says calculate absolute value. So it has to run this code first. And then if we step through a few times, we get the absolute value, we return it. So what are we going to print out at line 16? Yeah. So we print out once this function ends. So we print out 3.2. And now we go on to line 17. So now at line 17, we go back to line 4. What is going to be the value now? It's going to be 0 because that's what we pass in line 17. So value is 0. We step through. Absolute value is 0. So what are we going to print out? We print out 0. I didn't put the new line, but the 0 got printed out here. All right, Ben, did that answer your question?
Yes,
Okay, cool. All right, any other questions? Cool, so the final slide I have on functions, just the syntax. It looks hard when it's just on the slide. Again, the best way is to practice, but essentially we have the return type. This is going to be like a double string int char bool. The function name, it's going to be lower camel case, just like we do with variables. The main difference is we're usually going to use a verb here, whereas with variables we oftentimes use nouns. And then you have your list of parameters. And if you have multiple inputs, like we did with the add problem, you just put a comma between them. Yeah, parameters are, in the example of like the vending machine or the math example, they're the input. So in the vending machine example, it would be like the number that the user inputs, and then the return value is the snack that you get out of the machine. And so in the absolute value problem, it was we input negative 3.2, that's the parameter, and then we output the absolute value of 3.2. So parameters are just the input. Okay, and then at the end, we might return a value with the correct data type. Any questions here? Okay, so we're going to talk very briefly about testing. So far I've kind of been giving a lot of autograder stuff. As you noticed for the Wordle project, there is no autograder, so it's going to be up to you all to test your code, make sure that it works for the different test cases. So in groups, I'll just have you brainstorm what are all the different cases that once you finish coding, you want to actually test in your Wordle. So an example could be if you guess the word right, what do you want to do? What is the accepted outcome? I got the different cases. You can turn it up here.
Like if the word is not like 30 times checking for each letter, like different options. Like all green, yellow, and you have like very increasing like where you have really yellow.
Yes, I got the video.
I want to make sure
Because it's like something. Like when I put it, like I put it in order, like
I was brushing it on me.
how it is on the
Because
sheet.
I don't want to be confused.
I think it's my destiny.
I did my.
Like, bro, like I ain't gonna lie, like, that's what most of my time is just doing thinking. Like, I ain't did.
Okay, let's bring it back. Okay, so what are some of the different things you'll want to test after you finish your code? Yeah. Yeah, so give user right number of guesses, right? If you run the game and it allows the user to make 7 guesses, you know something is wrong with your code, right? So that's something that you should test before you meet with the Googler to get it graded. So give user the right number of guesses. All right, what else? Yeah. Yeah. Yeah, so making sure we correctly mark green, red, and yellow. The first section of your starter doc literally had you do like 4 different examples with red, green, yellow, and a word that mixes all of them. So you can put those when you test your code to make sure that it does it correctly for all of them. All right, what else? How about if the user wins, what do we want to make sure we print?
I mean,
Congrats,
won
and
in so many
yeah, these are wins. Make sure we output the correct number of guesses. Right? So if the user made 3 guesses, your code shouldn't say, congrats, you won in 4 guesses. That's something that you can verify by running the code. And then if the user loses, what do we want to print out?
The right answer.
Yeah. Cool. I think those are the main ones. We're going to go over the rubric on Wednesday, so don't book your grading appointment till we go over in class on Wednesday what the rubric will be. Just as an early heads up, it will be, have you tested your code? Do you understand your code? Is your code correct? And is the style correct? So did you do proper indentation? Did you add comments? Did you use good variable names? But we'll go over in more detail on Wednesday. After that class, just go back and look through your code, even if you've already finished it. Make sure you'll get all the points for the rubric, and then you'll meet with the Googler to get it essentially graded and checked off. Unlike this past week, we're going to make the hard deadline for everyone Thursday night. So the code has to be submitted on EdSTEM by Thursday night. The grading might happen Friday or later next week, but we're only going to use your submission from before Thursday night. So even if you have a later grading appointment, you still have to finish it by Thursday night. Any questions on that? As usual, if you need an extension, like let me know what's going on in your life, and I'm like we can give an extension if need be, but I need to know what's going on. It's not going to be like a blanket extension like I did for today's starter doc. For those of you that I emailed about missing the starter doc, check your email if you haven't seen it. Make sure you book an appointment for today. Again, projects are worth 30% of the grade in this class. If you don't do any projects, the highest grade you can get in the class is a 70%. Yep. Cool. So lab 6, if you haven't done lab 6, so if you didn't come last week, Wednesday or Friday, make sure you come in today at 5. We'll be going over lab 6, and then Wordle code will be due on Thursday. Step internship, if you're interested and you haven't applied, do it this week so that you still get priority for the interviews.